Consider the following statement: x equals y plus 5. This commands the computer to add numbers. But in order to add y and 5, the computer needs to know what y is. Thus, we first need to tell the computer to store a value in y. But how do we do that? We had a similar problem in the computer architecture course. We frequently had to store some value in a memory cell. Our solution was to construct an add-I instruction that adds cell 0 and a constant value. Since cell 0 always contains 0, the sum is always the constant value. Thus, when this add-I instruction is executed, the computer stores the constant value in a destination cell. For example, add I dst equals 4, src equals 0, imm equals 7, stores 7 in cell number 4. Let's try to translate this add-I instruction into a Python assignment statement as before. First, let cell 4 be y. Python does not have a variable that is always 0, so let's just say that a contains 0. Then the equivalent Python statement is y equals a plus 7. But now we need to store a value in a. Thankfully, Python allows both operands to be constants. So instead of defining variable a, we can just replace a with 0. As follows: y equals 0 plus 7. This statement says, add 0 and 7 and store the sum in y. 0 plus 7 is 7, so Python stores 7 in y. Not bad, but we can do even better. We can enter any expression to the right side of the equal sign. Since constant values are also expressions, we can write the following: y equals 7. What happens when this statement is executed? As before, the computer executes the expression on the right side of the equal sign and stores the result on the memory cell on the left. In our example, the right side is just the number 7. The expression is already evaluated, so the computer stores 7 in y. Now we also know how to store 0 in variable a. A equals 0.